Hi, thank you very much for joining us today, and it's a great honor to present here. So I'm going to present you the machine learning for social good, success stories and challenges. So it's a broad overview of what's been done in the field and what we can do better. So when I am talking about machine learning for good, I don't presume that anything else is machine learning for evil. So when we would like to define what it is, so I found out that a lot of research groups and a lot of industries, they define the social good in this context as corresponding to United Nations Sustainable Development Goals. And so in 2015, United Nations decided, so they set up the 17 goals they should achieve by 2030. And this is the broad challenges like stop the poverty and zero hunger. And so when I'm talking about social good, I'm talking broadly in the context of these goals. So I wanted to start with some overview of the field and working in academia. I decided to start with the statistics on the papers, but I realized that finding the number of papers devoted to the topic of machine learning for social good, it can be quite challenging because it's quite diverse, as we see in the development goals. They can be quite diverse, and it's not that I can find it by title. If they're doing machine learning for health, it's already quite developed field, and they will be quite specific. So I decided to look at the thematical workshops. So on the major conferences, ICML and NeurIPS, there are workshops after the main conferences, and they are on quite specific topics. So I tracked down these two conferences back to the 2013 and check for the workshops which will be correspond to machine learning for social good, and then check the number of papers in them. And I saw several talks when the professors talking to students and said that, or excuse me, I will be talking about something developed in 2016. Probably you think it's ancient in terms of the machine learning. And apparently it's true, because I couldn't find a lot of statistics prior to 2016. That's why you see these question marks. I know that there are workshops there, but I don't know the number of papers. And also in terms of the upcoming NeurIPS, it's also for the machine learning for the development world workshop. I don't know the number of papers. They haven't released it yet. But as we can see on the recent years, so there is a huge amount of papers published in the field, and just check the number of workshops increasing. So the last year at NeurIPS, there was 4 workshops broadly devoted to the machine learning for social good, whereas now it's 6 workshops, and for example, for machine learning for health, we have machine learning for health, we have fair machine learning for health, and medical imaging. And so that's in terms of the publication, and now I would like to just present what are the actions and activities going on in this space. So first, starting with academia. So this is the Data Science Summer Fellowship for Social Good. It's originated in University of Chicago in 2014, and it's been successful since that. So, for example, here you can see that you can now apply to Carnegie Mellon Summer Fellowship and do machine learning for good. Here in the UK, the Alan Turing Institute does a lot of activities in the space. For example, they partners with the University of Warwick this summer to do this Data Science for Social Good Fellowship, which I was just describing in the US. They also do events devoted to the topic. There are like more on the more permanent basis in the University of Southern California. They combined the social department and computer science and launched the Center for AI for Social Work. So it started as a joint project between the social scientists and the computer scientists. If I'm not mistaken, it was how efficiently distribute information about HIV among the homeless individual. So they were using the social network information, so to choose which individuals they can provide the information and then expect them to distribute this information further and how to do it efficiently. So the project was so successful that they decided to launch the whole center, and now they do a lot of work in the space. And so just to show how much is interest in the space, that there is just close the call for special issue on the AI for social good, and it's issue on for the philosophers. So they asking philosophers to present the papers how we should do AI for social good from a philosophical point of view. It's also a lot of interest in the space in the industry. So a lot of big companies and small companies do work in the space. For example, IBM have the department devoted for the science for social good. They have a lot of different projects. You can partner with them, and they also have some fellowship to do data science for social good. Google AI also doing project in the space. They also launched last year, so they awarded it this spring, but the start of the program was a year ago. It was the Grant Challenges AI for Social Good. So there was a hub of $25 million. So everybody can apply for the grant and present so what grant challenges they would like to address, and they don't only provide the money, they also provide consultancy from the machine learning perspective, because a lot of grantees were from the social work point of view, so they didn't have expertise in machine learning. Microsoft also doing a lot of work in the space, so they have the division AI for Good. It have 4 different programs, AI for Earth, where they mostly look for conservation, AI for accessibility, humanitarian action to help with the disaster response, and AI for cultural heritage. They also have grants, so if you would like to do something great in the space, you can apply. So here it's another example of the company. So it's Maxar, formerly known as Digital Globe. So they own satellites, and they are provider of very high resolution satellite imagery. And so they also do work in the space, and they partner with this UN Sustainable Development Goals program. And so if you go to their website, they have a book of their project directly connected to each of the 17 goals. So it's surprisingly that from space you can tackle the problems such as gender equality, for example. And also just to show how much is the interest is in industry. For example, McKinsey already have a report how we can apply artificial intelligence for social good. Also, there is a joint effort in the space. So each year in Geneva, there is a AI for Good Global Summit where policymakers, academic and industry, they join together and they discuss what are the best ways how we can tackle these problems. There are also specific companies who works directly only for ML for good, such as the DataKind. It's kind of a volunteer problem. If you're a data scientist and you would like to do something good, you can go to their website and volunteer your time. Or if you have a great problem, but you don't have a specialist to do that, you can go to them and they will find you some volunteers. Also, another example is a company called Wathwani AI. So they're based in India, and it's a non-profit, and they developing AI for social good, mostly in India. And there are a lot of more examples. So that was just a broad overview that there are a lot of interest in the space. Excuse me. So now to one of the two topics from the title. So what are the challenges in this space? And there are a lot of challenges. So the first, which a lot of practitioners talk about, is the problem definition. And I also write here as co-creation is maybe not a challenge, but it's very important that you need to go to the end users and co-create products with them to their needs, such that it will be useful. Just an example how challenging the problem definition can be. I would like to present you the project done by the company M-Crops. So they're based in Uganda, and the bunch of data scientists, they wanted to do something good, and so they went to the agricultural policymakers and say, oh, we would like to help. So they focused on the cassava. It's a major crop in Uganda. And the situation is that in Uganda, a lot of agriculture is based on the small farmers, and they may not have the capacity to invest in the technology and even to have enough expertise to fight pests, for example. So the government helped them, so they launched a series of surveys when the survey conducted in the field. They asked them about the crop situation, and it's all done in paper, and then they collected back, they entry it into the electronic systems, and then the experts can see it on a map, what kind of the disease situation, whether we should take some actions. As you can imagine, it's a very time-consuming process, and the first they propose what if we put the survey on the mobile phone such that it will be automatically electronic, and it will also automatically connect it to the geographical location. So that's great, but now if we already have it in electronic form, we can do better. So now we can have a photograph of a crop, and we can detect these diseases automatically. So they did that. They ask the farmers to provide the photos of their crops, and they automatically detect the diseases. But as when the disease is already visual on the leaves, it's maybe too late. So now the end users told them, so we need to catch this earlier. We need to look for the pests before it's too late. So you need to look at the back of the leaves and count the number of whiteflies. So now the problem converted that now they need to have these photos and to automatically detect the whiteflies. So this is just an example how the problem started with just to develop a mobile app, converted to the object detection problem for machine learning. The next challenge is gap between problem owners and problem solvers, and also we can call it as a very hard entry in the field. So if you have an average postgrad student which would like to devote his spare time, his or her spare time to AI for social good, it can be quite problematic because they need to find a collaborator in the field. They need to define the problem, and we already see how problematic it can be. They need to get the data, they need to get it ethically. They need to develop the algorithm, they need to verify the algorithm, they need to deploy it in the field, they need to collect the feedback, and then the loop starts all over again. And it can be problematic because maybe our student just wanted to develop a cool machine learning algorithm and do it for good. And to address this issue in this AI for Good Global Summit in Geneva, they launched this program AI Commons. This is the platform where problem owners and problem solvers can find each other. And similar data kind, as I already explained, where you can volunteer your time or you can propose a new project. The next challenge is lack of training data. As we already see that the problems in this domain can be quite tricky. You need to be creative and when you already define the problem, it can be quite a new problem, and you don't have the benchmark data when you can train your favorite neural net and the problem solve. So example for this is work done in the University of Massachusetts. So they these machine learners, they collaborate with ornithologists and decided to understand the bird migration. And so maybe bird migration in the US, and so maybe in the US there are no sensors specifically to track bird migration, but there are a lot of weather radars. And so they realize that on these weather radars they can detect birds as well. So they feed the radar measurements to the neural net, and then they expect them, the neural net, to have the segmentation map where they can discriminate between precipitation and the bird's movement. And then they can use it globally on the whole US map, and then build the map of the migration once they separate the precipitation from birds. The problem is that nobody has done that before, and so we don't have the training labels to have this segmentation. And as we know, the neural nets requires a lot of training data. So their workaround was that with the novel radars, they can actually automatically segment birds from precipitation, and then they use weak supervision to use all historical data for training. The other problem is, even if you have data, it can be unreliable. And it's also example from agriculture. The company Wathwani AI I mentioned before. So they also wanted to help agriculture in India, and here they address the cotton. So they went to policymakers and says where we can help. And so the policymakers have a whole framework how they can increase the income of farmers. It's also in India that it's mostly small farms produce all the crop yield. And the policymaker says that the first thing where you can help is reducing the crop losses. And in order to reduce the crop losses, we need to detect when there is a crop disease. And the crop disease is defined as we have the number of pests in the field higher than a threshold, then it is a disease situation and we need to do something. And the way how they did it before, they have this sticky thing in the field, and so the pests are stuck in the thing, and then people just by eye roughly estimate the number of pests on this thing, and then they extrapolate the information. As you can imagine, it's not very reliable count, and the whole process afterwards depends on this count. So what they did, they develop an algorithm to automatically detect it. I don't know where they find the training data to do that, but apparently this count were much more reliable than human estimate by eye. The next challenge is sustainability of solutions. So if you overcome the previous mentioned challenges, in order actually to relax and enjoy yourself that you've done something good, you need to ensure that your solution which you found is sustainable and in actually bringing the impact. And to do that, so when you develop your machine learning algorithm and it's working, you need to incorporate it to the actual product. Normally, when you go to the field, they already use something to tackle the problem, and you would like just to improve it. So you need to incorporate your algorithm to the existing system. And then, in order to bring the impact, you need to scale your product to bring the actual impact. And when you've done that, you need to ensure that in 2 months, in a year, these products still bring in the benefits that people with whom you communicated, they have not left, and the new people have not forget about your product, and that it's actually bringing the good. The next problem is universal for all research, but it's quite important here. It's unintentional harm when we wanted to do something good at the beginning, but then we have not looked for all circumstances, we have not think of all errors which our solution can bring, and ended up with something disastrous. So this is an example provided by Partnership on AI. Partnership on AI is partnership among a lot of AI researchers, and so they did the report on US criminal justice. So in here in the plot you have the incarceration rate, i.e. the number of prisoners per 100,000 population in the developing countries. And on the top it's United States. As you can see, so its rate is much higher than any other developing countries. They realize that it's a problem and they need to tackle it. And the policymakers, hopefully with good intention in mind, they pass this bill in California, where among the others they mandate to use machine learning risk assessment tools for pretrial detention decisions. So they know that there can be bias in human decision making. They know that sometimes the decisions is not based on evidence, so they wanted to bring some objectiveness there. So why not to use this hot machine learning to do that? But if anybody have worked with machine learning algorithm, they quickly realize that it's quite premature to use these tools to literally define human liberty. And so the Partnership on AI, they produced this report where they produce 10 recommendations which the tool first need to satisfy before it can be used in real life. And this 10 recommendation is based on these 3 main concerns. And the first one is validity, accuracy, and bias in tools and data. So machine learning is based on data, and it can be as objective as the data we feed to it. So if we feed all the historical data with all the biases in it, it will be as biased as the whole history. With the scale of these problems, it can just amplify all the weaknesses of previous human decision making. And also it's important to determine the threshold. So as we know, also in standard classification problem, we have some score function. We define a threshold. Everything above is class 1, everything below is class 2, and we're happy. So as long as we are talking about cats and dogs photos, if we defining this threshold, if we classify a couple of photos of cats as dogs, it doesn't matter. But if you have 2 individuals which score function, even if we assume it's quite objective, it's true score function of whether or not they should be free. If you have 2 close individuals and we just happen to define the threshold between them, it just means one is free and one is in jail. So we need to be careful with these thresholds. The second major concern is the human-computer interface. So we need to train the users, i.e. lawyers, how to use these systems, what kind of information they should feed to it, how they should collect it, and how they should interpret the results. And also from the technical point of view, the decision making in machine learning here should be quite transparent. It should be interpretable. It should provide the error bars such that the lawyers see that this decision is quite confident and this decision is not. And the final issue is transparency and accountability. So as I mentioned, so these decisions should be transparent, they should be monitoring and auditing, and they should have independent reviews. So just because we are trying to address quite an important issues, we need to be sure not to have unintentional harm. We need to double check everything that nothing will go wrong. And all the rest of machine learning challenges are even more important here because most likely, if you would like to do something for social good, you would like to do it for already vulnerable community. And so if something is wrong, it will hit them as twice as before. So just need to be careful. So I hope I hasn't scared you too much. And in order to diminish the scariness, I would like to present you some success stories that overcome all these challenges, and so we can still bring this social good with data science. So the first example is disaster management. This is the work done in our group, and this is my amazing collaborators. So imagine that the disaster strikes the region, and now we have the disaster responders which need to distribute their resources to provide help. So they need to understand where their need is needed the most. So what can we use? Luckily, such a company as Digital Globe, when disaster strikes the region, they release for free their very high-resolution satellite imagery, where you can identify by eye, by comparing before and after imagery, where the most disasters, where the most damage happened. But it's just too time-consuming for disaster responders to check the whole region to identify this area. Luckily, again, we have a lot of volunteers all around the world which are happy to help. So we can launch a crowdsourcing campaign, for example, on this wonderful platform, Zooniverse, which was developed in physics department in Oxford. And we can ask people to check before and after imagery and label where is the blocked road, where is the building damage, and so on. But if we ask two different people to label the same region, most likely they will provide labels quite different. And so what should we do? How should we combine, and who should we believe? So there was an algorithm developed in our group, so where we can combine all these unreliable crowdsourced labels to diminish all the biases, to weight the volunteers according to their reliability, and provide the consensus answers in the form of the heat maps. And now the disaster respondents can use these heat maps to understand where the help is needed the most. It's all great, but can we scale it? So every time the disaster strikes the region, we need to collect a lot of labels from volunteers. It's also time-consuming for them. Then we need to combine this and provide this information. Is it possible to scale? So here we provided the extension of this previous algorithm, BCC, so we added the neural nets which will be classifying the raw satellite imagery. The whole algorithm is simultaneously provide the consensus from the crowdsourced labels and train the neural net. And now we can feed this neural net as much data as we want, and it will gives us the automatic answers. So we evaluated these methods on two case studies. So first is damage detection. Here we asked, it was the paid crowd, so it was just 13 crowd members, but they label a lot of data. So we asked them to draw bounding boxes around buildings and then label damages on them. Then we extracted the image patches from these bounding boxes, and we wanted to classify these image patches to three classes: bounding box, undamaged building, and damaged building. Interestingly, in this data set, it was high discrepancy in labels. Almost 30% of the objects were assigned to different classes. So for the crowd-sourced problem, it's quite a lot. And so it's just results. We've shown that, of course, our algorithm is the best, and you can see that it's quite consistent among the different cross-validation runs. The second case study is mosquito detection for malaria prevention. In our group, there is a running project called Humbug in collaboration with Kew Gardens. They would like to tackle the malaria problem, and one of their goals is to develop an app which will be listening to the background noise and warning a user when it hears a dangerous mosquito. So the idea is that not all mosquitoes carry malaria, only quite a few species, and different species have distinctive sounds. So we can hopefully use machine learning to classify different species and then to warn user only when there's a dangerous mosquito around them. And to first tackle this problem, again, we don't have labeled data for a lot of mosquito sounds, so there is a crowdsourced campaign now at the university. You can go. Sorry. Oh, no worries. Sorry. So you can go to Zooniverse and label some data if you want to. And so you will hear for 2 seconds audio clip and just need to answer, did you hear mosquito sound or not in this clip. So now we just want to classify mosquito versus background, and then the next step will be to classify the different species. So we use this data. So we had over 1,000 crowd members. It was the data last year, so now we have even more. But the interesting features about this data is quite sparse. So whereas in the first case study we had the paid crowd, and a lot of the labels, they were a lot of the data points, they were labeled by different crowd members. Whereas here we can have a crowd member which who just labeled 5 clips and then they left. So we have a very sparse matrix of crowd labels, and we have a very imbalanced data set, because in majority of the cases there is no mosquito, and so it's just rarely we see the mosquito sound. Hopefully we can hear it now. No. Let's check. No.
Just go to settings and
no worries. Okay, so there is these slides online, so you can check the mosquito, or you can go to Zooniverse and label some data. So this is just example how the mosquito sound looks and how no mosquito sounds looks in the spectrogram, and we feed this spectrogram as an image to CNN. Yeah, and this is again some quantitative results. It's all good, but it was our like sandbox to have some experiments in the lab, quite relaxing. But we actually deployed this in the wild. So the solution was successfully implemented during the several operations, most recently after the Hurricane Dorian in Bahamas. And so here we collaborating with Rescue Global and Zooniverse and now Lancaster University to build these heat maps and to provide it to the first responders. So this is an example in more details for the operation after hurricanes Irma and Maria in 2017. So there was, as I mentioned, there was a project launched and Zooniverse platform where users were provided with before and after imagery, and were asked to label blocked road, flood, temporary settlement, and structural damage. Then the labels look like that. So you have some ID for the crowd member and their label and the location of their label in the image. So the at that time it was the BCC algorithm. It determines reliability of each crowd members. It weights them accordingly and aggregate all the annotation, provide these heat maps, and we had the feedback from disaster respondents that they are useful. These heat maps were spread into several NGOs and were successfully used. The second example is it's work in progress in conservation. We are working with zoologist Ilya Duperch. And so the idea, can we monitor elephants from satellite imagery? So elephants are big enough, and the satellite imagery are high resolution enough to see them, kind of. So we'll see it in a minute. So, but even with the highest resolution for the satellite imagery we have now, the grown elephant can occupy less than 15 pixels, so they're quite small. So it's challenging, but we decided to check whether the current state of the art machine learning can actually detect them. So this is an example of satellite imagery. Can you see elephants on them? They are. And you can see, so the red bounding boxes is the ground truth. The green bounding boxes is detection by the algorithm. So as you can see, it's already doing a great job. So I got this result just yesterday and was quite surprised to see them. So it's we experimented with different background. As you see now, it's a forest, and for human, it's more challenging to see them here, and so here they are. And actually, in this example, we have the perfect detection. So it's already very promising results. Hopefully, it can be used to survey elephants. So the next examples will be from our others, and it's not an exhaustive list. It's just some of the projects which were excited for me, and I wanted to share it with you. So first is fighting human trafficking. It's work done by our organization Thorn with their partners, and so I don't want to be quite depressive and to put a lot of statistics about how big is human trafficking right now, even in the developing countries. So just to tackle on how we can do it with machine learning, how we can fight it with machine learning. So the technologies has democratized human trafficking. Now you can go to the website, so where there will be trafficking ads. As you can imagine, it's quite increasing the speed how we can find buyers and sellers. So it increases the problem quite significantly. Oh, sorry. Yeah, and these websites collect very informative information about the victims. So they have photos and telephone numbers. On the other side, we have the website with the missing and exploited children, where they also have photos and telephone numbers of missing children. So now we just need to connect them, this information, and this is what Thorn did with their partners. So they launched the product called Spotlight, where they matching this information from these two publicly available domains, and so they help to identify children victims. And so this is the impact up until last year, I think. So they had over there 37 37,000 cases in Canada and US, and they identified more than 9,000 children victims. And they significantly increase the speed how these cases can be investigated. So the next example is healthcare, and in this case it's from Google. They tackle the problem of diabetic retinopathy, so I don't know how to pronounce it, so the diabetes causes more sight losses than anything else, and so if it's early detected, it can be prevented. If not, it's loss of sight forever. So obviously we would like to detect as much cases as early as possible, and so they did the work. Can we do it automatically by analyzing the retina images? So here you can see healthy and diseased eye. And so they train a neural net, and they got the results which were close to the error of a certified ophthalmologist. So which is great. So now they are working on how to deploy it and how to use it at scale. Interestingly, so if you manage to notice the difference between the previous slides, so the images haven't changed too much, but the title changed significantly. So it's quite an interesting story. They had this huge data set for the eye diseases, and they have other information about the patients, such as age, gender, and they decided, can we use the same data sets but to predict all these different outcomes? And it occurred they could. So they had the accuracy to predict whether a person is a smoker or not, looking by the retina image with 71% accuracy. They also managed to predict the cardiovascular event with 70% accuracy. If you, as I was, were not impressed with this level of accuracy, it's actually the similar accuracy as you can have having your blood tests. And most interestingly, so they found this correlation between the retina images and the cardiovascular risk factors, which were not known before in the medicine. So it's I think it's a very inspiring story that we can use machine learning to generate hypotheses in medicine, as well as machine learning was used to generate new movements in Go after AlphaGo had made this very strange move in the game with Lisa Doll, and now professional players they use this technique, so they improve it further. So now it's a whole direction which was not known before, and I think it's quite an inspiring story. So the next example is tackling helping accessibility, and it's work done by Microsoft. So they launched Seeing AI app. So it's a free app. It's a talking camera for the blind. So the blind individuals, they can use this app, and they can point their cameras to the environment, and the camera will talk to them. So what it sees, so they can understand the surroundings. So the app can identify the people, and identify the emotions. It can read text, it can even read handwritten text. It can also be used to identify different products by the barcode, and so in order to find the barcode for the blind, it's also using the beep sound to find the right location of the barcode to the camera. Yeah, it's also just general describing the scene. There was one use mentioned that a person is taking a cup and pointing the camera to the street, and the app is just reading the names of the shops, so the person can understand what's the development in the area. Unfortunately, I can show you these interesting examples of this app, so I encourage you to go and look at TED Talk by Anudur Kul. So he's a founder of this app. If you would like to know more, he's very passionate about it. And another example is conservation again. So now you can guess my favorite topic. And this is work done by Microsoft. So as I mentioned, they have 4 divisions in their AI for social good, and one of them is AI for Earth. And they are doing this Wild Me program. So they're creating the wild book of animals on the planet, and they to identify animals. So not just this is giraffe and this is elephant, but this is giraffe Alice and this is giraffe Bob. So the idea they're using the citizen science and machine learning to scale this problem. So you have an elephant. An animal in the wild. You have a human or a person who can take a photo of this animal. Then a human user upload this photo to the platform. It is verified by scientists, and then they find the matching, if they can, of this animal to their database. Then they can track this animal, or they create a new entry if this animal hasn't been identified before. And so it's a huge boost in conservation science. So now they can track the animals, they can understand their movement, and if we understand them more, we can save them more efficiently. So the idea how it's done, so you have a photo first, you run the object detection to find all the animals. So they have the cascade of 3 neural nets. So they classify the predefined sets of species, they found the bounding box, and then they validate this bounding box, they assign the classification to bounding box, and also provide the viewpoint of this photo and its quality. And then we need to actually identify the animals, so surprisingly it's using like old-fashioned computer vision techniques. So they're using SIF descriptors at key points to identify whether the 2 photos correspond to the same animals. And it's interesting that different animals have different characteristics, how they can be identifiable. So for example, sharks they have the patterns on their skin which is unique to them, or whales, they can be identified by the age of their tail. And we have much more examples. So that was just a gist of projects which I encounter and which I was fascinated about. So that's all I have to say. So if you would like to stay in touch, just heads up, I'm leaving Oxford as of next week. So I'm starting as a lecturer in University of Bath. So look for me there, and I will be hiring. So University of Bath have a CDT program in AI. If you would like to join and join me to do something as cool as this project, please feel welcome. And now I'm happy to answer your questions if you have. Yeah.
One of the applications I don't think I quite understood, I was wondering if you could explain a bit more about the mosquito sound one. How does that get implemented in the real world? I saw like a wristband or something like that people were supposed to wear, or what was the application for the sounds of mosquitoes?
So the question was the application of mosquito detection, how is it implemented in the wild? So it's a mobile app. So the idea is it's already now can listen to the background and predict the mosquito sound or not. But the idea we can improve it further to classify the actual species of mosquito and warn only about dangerous species.
So it'd be like an alarm would go off or something when they...
Yeah, it will be like an alarm. Yeah. Yeah.
So you were talking about identifying something in AI or ML that may be successful and then scaling it out to make sure that has an impact. And then you said that there was another step to make sure that it's keeping that like lasting impact. Could you talk to more about where you've seen maybe like some successes or failures in that like lasting impact and keeping them up? Is it, I think you mentioned you just check in on like 2 months or a year, or is there any more like tips that you have to ensure that it's continually having that initial impact?
Thank you. So the question was, I mentioned that there is a challenge to keep the sustainability of the decisions, and what are the tips to do that. So generally it's you need to be engaged with the end user as long as possible. So once you develop, you ask them for the feedback, and also generally your solution, one successful solution will be not enough after some time. They can come up with new challenges which good for you. You can develop new algorithm, or the problems change completely, and so your old solution is not relevant anymore. So it's always good to keep this engagement. So don't know the other like more specific, rather than just you keep engaging with the end users. Any other questions? Yeah.
So at the beginning, you listed papers from ICML and URIC. What about FAT-ML or ACM FAT now? You looked at outside on purpose?
So the question was, I presented the statistics on papers only on ICML and NeurIPS. It was just for fun to have some statistics. I didn't have too much resources to check all the available resources, but obviously other conferences, they're tackling this problem, and I think maybe even more. For example, we had a huge boost in ICML last year. It was because it was co-located with other conferences, and so they have joint workshops together. Yes?
So thank you for the presentation, it was very interesting. And I just wanted to ask if someone would like to work on something like this on their free time, would DataKind be the website that you recommend, or that somebody gets involved with this, or something else?
So the question was if somebody would like to volunteer their free time to this kind of problem, would be DataKind be a source of contact? Yes, maybe. So also check these AI comments. So it's also new for me. So knew about them when I was preparing for this talk. So also heads up, I heard about DataKind. They are overwhelmed with the amount of work they're doing. So if they not answer you straight away, it's not because they mean, they just don't have enough capacity. But if you keep pushing, so probably you will go in. Just also an example, so my friend is going to have a project, so he's a ML professor, and so he was talking with his dentist during the appointment, and now they're going to have a project to identify the diseases on X-rays. So just talk to people. So if you would like to volunteer, maybe you will find this solution. But hopefully, this platform I mentioned, maybe there are others, they can boost these collaborations.
Cool, thanks.
So you mentioned a few things going on. In general, if you take like a helicopter view, what do you think is still lacking? Where is AI not combined yet with social group? Where is the most progress to be made?
So the question was, where is the biggest gap in existing AI? So for social good, where is the biggest gap for that? I think maybe this reliability and as I mentioned with the example of unintentional harm, that may be it. So we have a huge noise now around AI and machine learning, and all people are excited, and which is very good, but they can be overly excited, as we saw with this bill. So we just need to make sure so that we are not yet on the level when we can solve everything. So we still have limitation in the products. We need to develop them further, but we also need to stop public to try to intervene the life-threatening decisions. So we know these adversarial attacks. So if we know that, probably we don't want machine learning algorithm to make an operation on ourselves. So just to make sure that we need to have very reliable solutions and checks. Any other questions? Okay, thank you very much for your attention. Thank you.